All right, this is on page 9. We'll call this calculating pH. Go ahead and make sure that you have your Cornell notes set up on page 9. Okay. Calculating pH. Let's get some background info first. All right, so background information. Let me draw out a strong acid. Hey, here's a strong acid. And a strong acid always has a hydrogen attached to it. And whenever you put a strong acid into water, what happens is that this H dissociates from the strong acid and attaches to the water, such that whenever you put a strong acid in water, you always get H3O+. And with a strong acid, all of that H will dissociate and attach to the H2O, making hydronium. So we could say, you guys know what these 3 dots mean? Anyone? Therefore. That means therefore, believe it or not, the concentration of the acid is equal to the concentration of H3O+. This is not true of a weak acid or a weak base. Weak acids and weak bases do not dissociate all of the hydrogen. So we cannot do this process, we cannot calculate the pH of a weak acid unless we do a couple extra steps. But we're going to start here with talking about strong acids and strong bases. All right. To do that, we're going to talk about logarithms first. How many folks out there in their math class have heard the word logarithm? A couple of you guys. Good. Let's write out the word logarithm. So those of you who haven't, don't worry, there's a button for it on the calculator. They're pretty simple. Very basic concept. We're going to say a logarithm is the opposite. Anybody know? Of what? Of what? Of exponents. With pH and with other parts of science, we deal with very large numbers, and back before calculators existed, those large numbers were really difficult to deal with, and so logarithms were invented as a way to calculate very large numbers and do math with very large numbers or very small numbers. So I'm gonna write that down. I'm gonna put like a little bracket underneath the word logarithm and put an arrow. Invented to easily deal with or very small numbers. pH uses a logarithmic scale, and so that's why we're talking about logarithms right now. But before we get to calculation of pH, what I want to do is just kind of talk about what the parts of a logarithm are, so that when you calculate them using our calculator, you kind of know what's going on. All right, anybody need to be on the slide still? Everybody's done? Because we're going to move forward. Okay, at least for my slide, I've got to. Okay, so let's do like 2 columns maybe. We'll say if on one side and then on the other. N is equal to, let's say 10 to some number p. You would agree, right? Like if p is equal to 2, so 10 to the second, n would be 100. Right? Or if p is equal to 3, we'll call that the power, right? So if 10 is raised to the 3rd power, then n would be equal to 1,000. So like I said, a logarithm is the opposite of an exponent. So what's the opposite of what we're looking at over there? Well, p is equal to the log. It's called base 10, so I'm going to make this little subscript n. If you wanted to figure out, let's say you had an equation that looks like that on the left, and you were like, n is equal to 100. Okay, well, what's p equal to? What do we raise 10 to equal that number? You can do it with a logarithm in our calculator. Let's do another kind of example. Let's write one out, actually. Let's say that 10,000, 1, 2, 3, 4, there's 4 zeros. I'm sorry, don't put it there. I apologize. Let's say that 10,000 is equal to, hey, what did I raise 10 to here? Who said it? 4, good. So what is the log of 10,000? What's the log base 10 of 10,000? How do we write that out? Log of base 10 of 10,000. What's the answer? What is it? 4, yeah. What do we raise 10 to equal to that number? Well, we raise it to the 4th power. So the p is equal to 4. What's up? Yeah. Okay, how about if we went the other direction? What if we said, okay, our number is a really small number, 0.0001. Okay, well that's actually 10 to the what power? Anybody know? It's not 4 because it would be 10,000. What is it? It's -4, good. So 10 to the -4th power is 0.0001. All right, I could say, hey, what is the log base 10 of 0.001? The answer would be -4, good. Let's write that out on our other side. So it's, again, the opposite of, right? Opposite of something that you're familiar with, exponents. Logarithms are opposite. So we say log base 10 of this really small number, well, that's equal to -4. What do we raise 10 to equal to that number? We raise it to the -4th power. you can maybe see how we'd want to use logarithms, right? I mean, think about hydronium concentrations. Hydronium concentrations are really small numbers, like 0.000000082, right? Or in other words, let's say, what did I do? 1, 2, 3, 4, 5, 6, 7, 8. In other words, it is 8.2 times 10 to the negative 8. We're dealing with these really small numbers. Well, I can take the log of that number and I can get something that's actually kind of simple to deal with, right? If I wanted to check out the pH in a pool, I don't want to have to be like, okay, the pH is 0.000000082. I can say the pH is 8.1 or something like that. Can all of you guys grab your calculator? We're going to do this problem right now. I want to show you where the log is. So let's take the log base 10 of 8.2 times 10 to the negative 8th. Here's what we're going to do. I want you guys to go to the second button. So in the upper left-hand corner, everyone needs a calculator. Click that gray button in the upper left-hand corner that says second. Click that. And then click the PRB button. It's kind of below the percent sign. Look for that. And if you click the second button first, the 2ND button first, it shows up, right? You guys see log with a little parentheses? You see that? Go ahead and push enter. Then we're going to type in 8.2. Remember, there's a button for times 10 to the on these calculators. We'll say negative 8th. Close the parentheses and push enter. What is it? Negative 7.1, we'll call it. Times, notice how it says times 10 to the 0, right? So really you can just think of it as 7.1, negative 7.1. So what was the log of that? It's negative 7.1. Well, gosh, look, 10 to the negative 7.1 is approximately equal to this, right, if we wanted to go the other direction. All right, I'm getting ahead of myself. I want to watch a video. All right, so from that video, we get a couple different things. So from the video, we can say the following. pH, the concept of pH in chemistry, pH uses the logarithmic scale. We're almost done with our notes here. pH uses the logarithmic scale. So we really actually get two equations or two formulas out of this that we can use. We can say H3O plus, the concentrate. Remember, whenever we put brackets around something, it represents concentration. So the concentration of H3O plus is equal to 10 raised to the negative pH. So if we knew the pH of a substance, we just say in our calculator, 10 to the negative of that pH will give us the concentration of H3O plus when we're dealing with a strong acid or base. Or we have this one, you saw this in that video. pH is equal to the negative log of the hydronium concentration when we're dealing with a strong acid. So that example that we did earlier, remember it was a negative, I think it was like negative 7.1. Had we taken the negative log of that, negative times a negative, the pH would have been 7.1. Let's do a couple examples. If you guys bear with me, I've got some examples printed for you, and let me go cut those up and give them to you. Okay, so let's get this going. Let's do the first one. Yeah, we're going to glue this into our notes. So here's the first one. Read it. The pH of an acid is 2.3. What is the concentration of hydronium, H3O plus? Well, hey, gang, look. We know the pH, and so we're going to use the formula on the left. I'm going to write it out one more time for us.
We write this on page 8?
No. We're still in the notes. Not on page 8. This is still page 9. Okay, so concentration of H3O plus is equal to 10 to the negative pH. Gang, look, is equal to 10 to the negative what? What's the pH of the solution?
2.3.
So we're going to say negative 2.3. Go ahead and put that into your calculator. How do you do that? Gang, there's a button for it. Everyone grab your calculator. Grab your calc. I want you to type in 10, and then look for the 7. Do you see 7 on your calculator? Look to the left. It's a little cute caret. That's your exponent button. Click that little button and type in negative 2.3. Push enter, and you get the answer. You don't know how to do it, what? Is that what you said? Type in 10, and then there's a button, there's an exponent button to the left of the 7. Click that, and then type in the pH, right, the negative pH, so negative 2.3. We're going to round that answer to the nearest tenth. You get 5.0 times 10 to the negative third. All right. Any preguntas about that one? Let's do the second one. All right, Mr. Justice. Good. Grab your second one. All right. Anybody still need this up? Okay, let's do the second one. We're going to hold on to the third one, do that later, tomorrow maybe. All right, gang. Second one says the concentration of a strong acid is 5.0 times 10 to the negative third molar. Hey, that's the answer from the last one. What is the strong acid's pH? All right, well, probably can answer that question now, but we're going to do it the old school way. Let's say pH is equal to the negative log of the hydronium concentration, which is 5 times 10 to the negative third. Go ahead and take your calculator. How do you do this? Start off with the negative sign first. Do not use the minus sign. Use the negative sign below the number 3 button. Click that. Go to second PRB and click log. You're going to type in 5 times 10 to the negative third. Remember, there's a button for times 10 to the. End or close your parentheses. Click enter. And you get what? 2.3. It shouldn't be negative. No, if it's negative, you didn't follow the formula. Remember, it's the negative log of the hydronium concentration. What's the answer, gang? 2.3. Yep. Our calculator says it's 2.3 times 10 to the 0. You can write that out and be just as correct if you wanted to. All right, so that's how you do that. We're going to save the third problem, you guys, until tomorrow. You might as well just glue that into your notebook right now, though. Are there any questions about using logarithms for pH calculation? Nobody? I don't believe you. Yeah, Jason. I use the formula for question number 1, the first one. The formula is 10 to the negative pH is equal to the hydronium concentration. So I just raised 10 to the negative, the pH was 2.3, so negative 2.3. And whatever the calculator told me, that was the answer. Okay? All right. Gang, we have some